Okay, this next video is going to walk us through how to solve application problems where we're given a mean and a standard deviation and asked to calculate the probability of a certain event based off of that information. The work that we're doing is going to be almost exactly the same as just looking at probabilities or calculating probabilities based on z-scores that we just did in our practice or in the previous video. The difference is we have to calculate the z-score associated with our random variable before we get started. Okay, so let's figure this out by going through some examples. So we're told the heights of young women are approximately normal with a mean value of 64.5 inches and a standard deviation of 2.5 inches. We want to figure out the probability that a randomly selected woman measures less than 61.5 inches. Remember, we've got our three different types of probability questions we might be asked. We've got less than, greater than, and between questions. It's important to pay attention to which type of question we're working with. So now when we're labeling our diagram, we're going to put the mean value in the middle. So we know my mean is 64.5. And so if I'm figuring out the probability that I'm less than 61.5, 61.5 is lower than my mean, I can do a sketch and get an approximation and try and connect this to the work we were just doing. Okay, so I'm trying to find that shaded area. So again, what I'm going to have to do first is transform 61.5 into a z-score. I need to figure out how many standard deviations 61.5 is below my mean value of 64.5. So I use my formula. Z is equal to x minus mu divided by sigma. Okay, I calculate my z-score. In this case, it's negative 1.20. Okay, I'm going to round to 2 decimal places where necessary because that's the precision I can look up in my probability chart. So finding the probability that a random woman is less than 61.5 inches tall is the same as figuring out the probability that a z-score is less than negative 1.20. This is just as though I shifted from an x variable to a z variable. And I know how to figure out the probability that a z value is less than negative 1.20. I look it up on the chart. Negative 1.20 is 0.1151. Okay, and so I can write my conclusion. The probability that a randomly selected woman measures less than 61.5 inches tall is 0.1151. Okay, let's look at the next example. It's still the same scenario where we're dealing with young women, so their average height and standard deviation doesn't change. This time, however, we're asked to figure out the probability that a randomly selected woman measures between 60 and 68 inches tall. Okay, the first thing I'm going to do is draw a picture to help me think about how the values I'm being asked to work with relate to the mean. The mean is always in the center of my bell curve, and I'm trying to figure out the probability that we're between 60 and 68 inches tall. Okay, again, because it's a between question, right, I'm going to use the same approach as if it was a between question just involving z-scores. What's different here is that I'm going to have to find the z-score associated with each of my x values. So for x equals 60, we calculate our z-score. Z for that value will work out as follows. If we put it into our calculator, do it alongside me, it works out to negative 1.80. Okay, for x equals 68, Again, if we do the calculation, it turns out to be positive 1.40. Right? And that makes sense. 60 has a z-score that's negative associated with it because it's below the mean. How far below? It's 1.80 standard deviations below the mean. 68 has a z-score of 1.40 because it's 1.40 standard deviations above the mean. Okay. Now that we have our z-scores, we can write our probability statements and solve the problem. So, the probability that a woman measures between 60 and 68 inches tall is the probability that our x variable is between 60 and 68. And that's equal to the probability that we have a z value that's 1.8 standard deviations below the mean and 1.40 standard deviations above the mean. Because it's a between probability question, we're going to calculate the probability that z is less than 1.40 and subtract from that the probability that z is less than negative 1.80. Looking up those values on our probability chart, and feel free to pause the video and look those up. I'm just going to write them in here. The first value comes out to 91 or 0.9192, and you can double check that. And the second value comes out to 0.0359. Subtracting to finish solving the question, we get a final answer of 0.8833. Okay. So what this means is the probability that a randomly selected woman is between 60 and 68 inches tall is about an 88% chance. Okay. Do one more example just to make sure that we're feeling confident with this. Okay, so what's the probability that a randomly selected woman measures more than 67.6 inches tall? Again, paying attention, this is a greater than question. When we draw our curve, we always put the mean in the center, and then we can label our value we're interested in our calculating probabilities based off of, either to the left or right, depending on if it's higher or lower than the mean. In this case, we're figuring out the probability that we're more than 67.5, so I'm shading the area to the right of 67.5. Okay, I'm going to scroll down and show again the summary of the steps that we follow. So what we're going to do is transform our x value, our value that's in the units of measure that we're interested in, into a z-score. We're going to figure out how many standard deviations that value is from the mean. So since we're figuring out probability based on 67.6 inches, I'm going to figure out how many standard deviations 67.6 is from the mean. So I subtract 64.5 since that's a mean, and divide by 2.5 because that's the standard deviation. When I do that calculation, it comes out to 1.24. Okay, so the probability that x is greater than 67.6, the probability that a random woman measures more than 67.6 inches tall, is the same probability as any time I have a z-score greater than 1.24. Because it's a greater than question, I can calculate the probability that z is greater than 1.24 by subtracting the probability that z is less than 1.24 from 1. I look up the z-score of 1.24 on my probability chart. Because it's a positive value, it's going to be on the second page. Okay, and I find that it comes out to 0.8924. I plug the subtraction into my calculator and get a final answer of 0.1075. and I can write my conclusion. And therefore, the probability that a random woman is more than 67.6 inches tall is 0.1075, right? So again, the key things we need to do are to draw a picture, we need to transform the variable into a z-score, and then we need to do some calculations, write some probability statements, and conclude with, so that it's clear that we know what we're finding, okay? So the next page in your notes has some practice problems to try. So pause the video, give them a try, and then resume it, and I'll write all of the answers for parts A, B, and C up at once for you to check your answers with. Okay, for part A, because it asks for the percentage of healthy men expected to have temperatures below 37 degrees Celsius, we find it turns out to 77.34%. As far as what percent are expected to have temperatures greater than 37.5 degrees Celsius, it turns out to 2.28%. And the abnormally low temperature would be 35.9 degrees Celsius. The abnormally high temperature would be 37.5 degrees Celsius. If you have any questions about this, please talk to your instructor, attend office hours, or book in for tutoring, okay? Stay tuned for the next video, which will be the last video in the course, looking at how we can figure out X values or values in the same units that an application question is posed in based on percentiles or probabilities.